Hello, ladies and gentlemen. Today we're going to be talking about how to find mean, median, and mode from a frequency table. So we're still talking about those measures of central tendency, but now we're going to be finding the mean, median, and mode not from the raw data set like we've done in the past, but from a frequency table or frequency distribution. So what you're going to need today is your notes and a couple foldables and then something to write with, and then you'll probably want a calculator so you don't have to do too much mental math. All right, we are going to get started actually with first finding the median and the mode from the frequency distribution rather than finding the mean. So we have this table here. We have values listed from 1 to 5, and then we have the frequency at which each of those values is occurring. So it doesn't tell us what our data values represent, but let's just imagine that there are a number of pencils in students' backpacks. What we're trying to say is that 4 students have 1 pencil in their backpack. 3 students have 2 pencils, 2 students have 3, 6 have 4, and 8 students have 5 pencils. So when it comes to finding the median for this distribution in this table, we want to find the middle number that has occurred. So the values that are listed, like if we were to go and list all these values, we would list like 1 4 times, we would list 2 3 times, 3 twice, and then so on and so forth. So from this raw list, where is the middle or the median? So how we're going to find that is we're going to add up all the frequencies and then divide by 2 to find the middle. So if we took 4 plus 3 plus 2 plus 6 plus 8, that is the sum of all the F's. If we took all these and added them together, we should get 23. Divided by 2 gets us 11.5. So we're looking for the 12th term. So how we go about finding that 12th term is if we look at, here, let me grab an eraser really quick. So if we look at each of those values, we're saying 1 was listed 4 times. We're looking for the 12th term. So this would be 4, 5, 6, 7, 8, 9, 10, 11, 12. So our 12th term is going to fall in this category, and the number that is our value or our data point is 4, because we're saying that 6 4s were repeated in the data set. So our 12th term is our median, which is at the value of 4. Finding the mode for the distribution is actually very easy because it's just going to be the one data value that has the largest frequency. So that, in this case, would be the largest frequency is 8, and our data value that corresponds to that would be 5. So the mode for this table or frequency distribution would be 5 because it occurs 8 times. So those are how you find the median and mode from a frequency table. Let's take a look at how to find the mean. But before we get to finding the mean from a frequency table, I want to first talk about a calculation called the weighted mean, because when we figure out how to find the weighted mean, this formula is going to be very similar to how we find the mean when it comes to a frequency table. The best example of a weighted mean in the real world is probably a GPA or a grade. Like when we say as a teacher that only 10% of our final grade at the end of the semester is homework and 90% is tests or something like that. In order to calculate your grade, the formula that's happening in the background is a weighted mean. So make sure you get this formula written down. It is W bar, which is, remember, X bar is like the mean, so a weighted mean would be W, is equal to the sum of each of the data values times their perspective or respective weights, all divided by the total amount of weights that are being assigned. So quite honestly, this formula doesn't make sense until we get to a context of a problem. So let's try a problem right away. It says listed below are the grades of a student's semester courses, and we're going to calculate the GPA. So we have math, history, health, and art for our courses. Our grades, our letter grades are A, B, A, C, and then the points that are assigned to each of those letter grades is a 4, 3, 4, and 2, and then the credits that go with those points are going to be as follows: 5, 3, 2, and 2. So our formula, remember, is the sum of X times W all divided by the sum of the weights. So luckily our table has told us what our data points are and then what the appropriate weighting system is with each of them. And that's where we're going to go next. So math is weighted way more than art or health is, and so on and so forth. And then, of course, each letter grade has a corresponding point value. So A would be 4, B 3, C 2, and so on. So what we're going to do is we're going to take each of the data values times their respective weights. So 4 times 5 is 20. 3 times 3 is 9. 4 times 2 is 8. And 2 times 2 is 4. The next step then is to take the sum or to total this whole column for our numerator, because our formula is saying we want to take the sum, or we want to add up each of those values after we've multiplied the data point times its respective weight. So they want us to take 20 plus 9 plus 8 plus 4. So 29 plus 8 plus 4 is 41. And then our formula says we also want to divide by the sum of the weights. So that's going to be the column of W. So 5 plus 3 plus 2 plus 2 is 12. So the weighted mean then is going to be that 41 divided by 12, which gives us a GPA of 3.42, because we round to 2 for GPA. So that would be the GPA for this particular student listed below. Okay, let's look at another example. Same thing. So most colleges use a scale, just like the one we did on the last one. If you have a letter grade, your point value is 4. If your letter grade's B, it's 3, C is 2, D is 1, and F is 0. And we're going to do another GPA for Joe. So, oh, it looks like we already took the credits times the weights. I guess I did that already. So here's our W times X column. So remember, a C was a 2, an A was a 4, A was a 4, D was a 1, and a B was a 3. So we took 4 times 2 to get 8 in this column over here. 4 times 3 was 12, 4 times 3 was 12, 4 times 1 is 4, 3 times 3 is 9. And then we need to find the sum of those multiplied together. So 8 plus 12 plus 12 plus 4 plus 9. Remember, because our formula is the sum of each data value times their respective weight. After we've done that, add that column up. That's the 45, all divided by the sum of the weights. So W bar is going to be 45 divided by 17. And 45 divided by 17 as a GPA is 2.65. That would be the GPA. Let's look at another one. And then this time they actually didn't give us the table. So we're going to make a table. So we're going to find Pat's overall grade, not a GPA this time. So we have the categories of homework, and then we have quizzes, and then we have tests. Okay? Homework, quiz, and test. Grades are often computed using the weighted average. Suppose that his homework counts for, so the weight is going to be 10% for homework, it's going to be 20% for quizzes, and it's going to be 70% for tests. That's the weight. And then his actual grades or points for each of those categories are going to be the X. So I'll say points. So that's going to be his homework grade right now is a 92. His quiz grade is a 68. And then his test grade is an 81 currently. So we're going to take W times X. So we're going to take 0.1 times 92 to get 9.2. We're going to take 0.2 times 68 to get 13.6. And then 0.7 times 81 to get 56.7. Now we're going to sum this column. So the sum of that column is equal to 9.2 plus 13.6 plus 56.7 is all 79.5. And then we're going to sum the weights. 0.1 plus 0.2 plus 0.7 is all just 1. So then our formula for our weighted mean, or for his overall letter grade percentage, would be 79.5 divided by 1, which is just 79.5%. That is Pat's overall final grade for the class. Okay, so understanding the weighted mean is going to help us find the mean of a group or group data or a frequency table or frequency distribution. So the first thing we're going to want to do when it comes to steps of finding the mean is we want to make a table, then we're going to find what's called the midpoints of each of those classes. We're going to multiply the frequency by the midpoint and then divide by the sum of the frequencies. So this formula is very similar. There's just an added step of we have to find those midpoints before we can take x times the frequency. So when we talked weighted mean, we had the sum of each data point times its perspective weight, all divided by the sum of the weights. Now instead of W, we're saying it's F, and instead of saying the data value, we're not going to have a data value per se, we're going to have a range of data values. So in order to find the range of data values times its perspective frequency, we're going to find the midpoint first. So let's look at an example. All right. So we are talking about university students that took part in a sponsored race, and the number of laps completed was given in the table below. So we don't have the raw data set. We just know that 2 students completed somewhere between 1 and 5 laps at this race. 9 students completed 6 to 10 laps at this race, and so on and so forth. So when it comes to listing out the data like we did in the very first slide of this lesson, we can't list the numbers twice because we don't know which of the numbers between 1 and 5 were listed twice. So in order to estimate for a mean, we're going to just assume the midpoint for each one of these. So we're going to say that the midpoint between these 2 values in our class limit is going to be what occurred twice. So the midpoint between 1 and 5, remember how you find a midpoint would be 1 plus 5 divided by 2, so 6 divided by 2 is 3. So that first midpoint for that first class is 3. Then it's 8, then 13, then the midpoint between 16 and 20 is 18, 23, 28, 33, and 38. So now after this step, it's very similar back to the weighted mean. We're going to take this column, the midpoints, times the frequency column, and that's what's going to be in this final column over here. We're going to take 2 times 3, which is 6, 9 times 8, which is 72, 15 times 13, which is 195, 20 times 18, which is 360, and so on and so forth. You could obviously use your calculator, but I have all the animations already created for you. And then just like we did with the weighted mean, when we find our mean from a frequency table, we're taking the sum of the frequencies times the midpoints, all divided by the sum of the frequencies. We need the sum of this column. So we need to add 6 plus 72 plus 195 and so on and so forth. And that is 1,828. And then also we needed to sum the frequency column because that's going to be our denominator. So it's going to be 1,828 divided by the sum of all the frequencies, which was 91. So let me grab my calculator. 1828 divided by 91 is 20.08. But remember, our rounding rules for mean means that it's going to be 20.1. 20.1 laps on average. 20.1 laps. Look at that. I already had it written down. Okay, now it also wants us to do another example of determining the modal class. So remember, finding the modal class given a grouped table or a grouped data in a frequency table is just looking for the frequency that has the highest number in that column. So 2, 9, 15, 20, 17, 25. It looks like 25 is the largest frequency. So that means that my modal class is going to be the class that has 26 to 30 laps. And then last but not least, we want to determine the interval containing the median, or the class limit that is containing our median. So we wanted to sum the frequency column, right? Which we already did. That was 91. Let's take that divided by 2. That's 45.5. If we round it up 1, that's 46. We're looking for the 46th data value in the set. So if we take 2 plus 9, that's 11. 11 plus 15 is 26. Plus another 20, our 46th data value is going to fall in this class. Because then our 47th data value would start falling here, and then all the way through to our 91st data value would fall at the very end in the 36th to 49th. So that means that our class that contains the median would be 16 to 20. The last thing I want to talk about with mean, median, and mode is how to find the mean, median, and mode from a stem and leaf plot. So it's not a group data set because a stem and leaf plot is not grouping it. It's still the raw data, but let's just talk about how to find the mean, median, and mode from a stem and leaf plot. Oh, it looks like we're just finding the median and mode. My bad. I guess I thought we were also finding the mean. So the median is going to be that middle number. So remember stem and leaves, how it's organized is like our data values are 15, then 16, then 20, then 27. So if we wanted to, we could relist out our data like that by listing it as 15 and then 16 and then 20 and 27, 28 and so on and so forth. So let's see how many data values we have in our whole entire data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if we take 21 divided by 2 and then round it up, we're looking for the 11th term because 21 divided by 2 is 10.5. Rounded up to 11, we're looking for the 11th term. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our median is going to be 37. And then our mode, hopefully this is familiar to you, the one that occurs most often. So in our data set, which number was listed the most often? It should be 42 because we have 1, 2, 3 42s and everything else was only listed twice. So our mode is 42. How we would go about finding the mean would just be like how we normally did finding the mean when we had a raw data set. You would take 15 plus 16 plus 20 plus 27 plus 28 plus 29 plus 29 plus 36 plus 36 plus 37 plus 37 and so on and so forth, all divided by our total number of data values, which is 21. And then you would have gotten your mean. But I guess this problem didn't ask us for that. So with that, I guess that is all I have for you today. So I want to thank you for taking good notes, and I'll see you soon.